Hello everyone, greetings from JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. In this session, I am going to explain about the CRC code computation using CRC 16 polynomial methods. So in the previous session, we discussed about the CRC 12 computation process. Now in this session, we are going to compute the CRC 16 process. So what is meant by CRC? CRC is nothing but a error detection technique which is operated in the data link layer. So the cyclic redundancy check is an error detection technique used in computer networks in the layers in the data communication and storage devices and embedded systems. So it uses 16-bit reminder. So to find the error detection process, it uses 16-bit reminder. So 16-bit reminder is the output for the error detection process. So here the scenario is what the sender computes CRC and appends it to the data. So original data is transmitted by the physical layer. So to that physical layer data, the sender computes the CRC code. The next receiver performs the same division operation on the receiver side. So sender side one operations performing and the receiver side operations are performing. So when sender transmitting the bits to the receiver side, the receiver receives the same data. If receiver receives the same data, then the error will not be occur. If it receives the data will be any noise or any other data, then it will be considered as error. So now if the remainder is 0, then the data is assumed to be correct. If the remainder is not 0, then error will be detected. So this is the way we can identify through CRC 16-bit reminder. So now the CRC working principle. How it works? The step 1 is what? To choose the generator polynomial. Choose the generator polynomial, correct generator polynomial. If you are having the data bits like 10, 101, so to this calculation, to this computation, we need to choose the correct generator polynomial, either CRC 12, either CRC 16, either CRC CCITT. CRC 12 computation process we already discussed in the previous session. Now the CRC 16 we are going to discuss. So the generator polynomial is x power 16 plus x power 15 plus x square plus 1. So that can be computed as like this. So how it can be computed as 1 into x power 16 plus 1 into x power 15 plus 0 into x power 14 plus 0 power 13 plus 0 power 12, like that up to 1 into x power 2 plus 1 into x power 0 plus 1. That is the generator polynomial computation. So from this generator polynomial, the binary bits are what? This one. So 1, 1, 0, 0, 0 up to x power 3. The next x power 2 is 1, then next x power 1 0 and again 1. So this is the overall polynomial binary code of the CRC 16. The second step is what? Appended zeros. If the generator has degree R, append R zeros to the data. Append R zeros to the data. So the generator having the degree of 16 or 12, then append R zeros, that 16 zeros to be added. So example, if the data is having this one, if CRC 16 is appending, if the CRC 16 is appending, then you need to append 16 zeros to this data. You need to append 16 zeros to this data. So now the data appended data is what? This one. So this first part is what? Data, and this second part is what? Appended zeros based on the degree. Appended zeros based on the degree. So this is the step 2. And step 3 is what? To perform the binary division, modulo 2 performance. The perform XOR division using the generator polynomial. So the rule is what? When you are performing 0 XOR with 0, then the result will be 0. 1 XOR with 1, then result will be 0. 0 XOR with 1, then result will be 1. And 1 XOR with 1, then result will be 1. So in the overall bits, if the left bit is having 1, then you can perform again XOR division. If the left bit is 0, then you can leave that 0. and the obtain remainder. Step 4 is what? Obtain the remainder. So after doing all these calculations, after doing all these left bit XOR operations and the 0-bit leaving operations, then the obtained remainder will be the CRC 12-bit remainder. The obtained remainder is what? 12-bit remainder for the CRC 12, 16-bit remainder for the CRC 16, and 16-bit remainder for the CRC CCITT also. Only the difference between CRC 16 and CRC CCITT is the CRC 16 comes with x power 16 plus x power 12 plus x power 5 plus 1, like this. But when comes to this CRC CCIT, x power 16 plus x power 15 plus x power 2 plus 1, like this you can see the computation process. So it is a computation process. And step 5 is what? Transmit, that overall transmitted frame. So after adding the obtained CRC remainder to the data, the transmitted frame is the original data plus CRC remainder. So the combination of this data is what? Transmitted frame. This transmitted frame will be transmitted to the receiver side. Transmitted to the receiver side. Now we'll see the example of CRC 16 computation with the given data. So the given data is what? 1, 0, 1, 1. If you take longer bits, then the computation calculation process will be the long. So you need to take the shortest bits. So 1, 0, 1, 1 is the shortest bits. So here the data is what? 1, 0, 1, 1. So CRC 16 generator, from the generator polynomial, the bits are what? This one. So 1, 1, you can divide it as 1, 1, 0, 0, like this. You can divide it 0, 0, 0, 0. So 1, 1, 0, 0. Then next 0, 0, 4 zeros. Then next 4 zeros. Then next 4, 0, 0, 1, 0 and 1. So like the way you can split them into the comfortable ways. So now the data will be added. So total overall this generator will be added. Now the step 1 is what? To append 16 zeros to the data. Append 16 zeros to the data. So now I added 16 zeros because of the CRC 16 polynomial. We need to computation to the data. So this is the data and 16 zeros will be appended to the data. Now after appending the data is what? The dividend 1011 with all appended data. So this is the dividend. We can call it as a dividend. And the divisor is nothing but what? The CRC 16 generator. 1100 and 0000 This is the divisor. Now we can perform the XOR operation between these two. So when you are performing the XOR operation, performing modular division, when the bit will comes, the leftmost bit will be 1, then it will be, you can perform XOR operation one more time. If you are having the 0 on the left side bit, then you can able to shift the 0 to the next level. So here if you see, the dividend is what? 1011, 0000, 0000, 0000 and 0000. That is the dividend from this one. Yes, right. The next divisor is what? 1100, 0000, 0000, 00101. Now take the first 17 bits as per the degree of this polynomial. Take the first 17 bits. Now 1011. So till now 4, 4, 4, 16, and with this one 17 bits are over. So now the 17 bits are added. So now since first bit is 1, perform XOR operation. So first bit is 1, perform the XOR operation. Now performing the XOR operation. After performing, when you are doing this XOR operation, you can see the binary calculations. What? 0 and 1. So 0 and 1, it comes output as 1. And as for the 0, 0, it will becomes as 0. For the 0, 0, it comes as 0. For 1, 1, it can comes as 0. And for 1, 0, it will be 1. And 0 and 1, it will be 1. So like the way each and every calculation will be happen. So after this all bits, you can see the left bit is what? 0. So drop leading 0. When you are having the left bit is 0, then drop leading 0. When you are having the left bit is 1, perform XOR one more time. So now the 0 will be dropped. So after dropping the 0, the bits will be like this. So 111, 000, 000, 000, 0101. Now this is the drop leading 0 bit. Now we can have the one more bit to the bit, one more bit to the next bit. So that 0 will be added to this entire bit. 0 will be added to entire bit. Now this entire bit having starting with 1. So starting with 1 we can use to perform XOR operation one more time. So now this one is the 1100 is the second bit, second time bit, after removing and after changing, after bringing next bit to the sequence. Then performing with the divisor operation. The divisor is this one and the dividend is this one. Performing the operation same 001 and all. So out of all these you can see drop leading zeros. When you are having the left bits are 0, you can drop the leading zeros. You can drop the leading zeros. When you are having the left bit is 1, your left bit is 1, you can perform XOR operation. So now here if you see the drop leading zeros are dropped. So after dropping these leading zeros, the bit sequence will be this one: 1 000 000 000 000 01 111 01 1111, right? So after dropping these zeros, the bit sequence is this one. Now to this bit sequence you can bring the next bit 0 to this one, next bit 0 to this one. So now the bit sequence will be added here. So here the left bit is what? 1, and bring another bit to make 17 bits. So here 16 bits are there and you can make it 17 bits. So after adding 17 bits, the left bit is what? Again 1. Left bit is what? Again 1. So you need to perform XOR operation again. So after performing this XOR operation, again you will see you will get the outcome as bit sequence. In this output bit sequence, you can see the 0 and drop the leading 0. Drop the leading 0. So after dropping the leading 0, the bit sequence is what? This one. So to this bit sequence, again bring next bit to this sequence. Again bring next bit to this sequence, because the bit sequence has to be made 16-bit reminder. So to become 16-bit reminder, we need to add the remaining all bits to this bit sequence. Now the bit sequence is added and here it will come 1, left bit is 1. Now performing fourth XOR operation, So after performing the fourth XOR operation, again it will become 0. Again it will come left bit as 0. So now drop leading the 0 and remaining all the bit sequence will be there. So for this bit sequence, again you need to take the 0. So these zeros you can compute as the number of bits are available in the overall generator. So now 0 will be added. So after adding the 0, the bit sequence is having the left bit is what? 1. So because of the left bit is having 1, we can perform again XOR operation. So 1 same for this all, this is the dividend, and the divisor is what? This one. So when you are performing this divisor to this division operation, the output will be like this. So 0 1 0 0 0, all this will you can see. After performing this fifth XOR operations also, if you see the drop leading 0, you can drop leading the 0. So after dropping the leading 0, then the bit sequence will be like this. So like the way you can continue the similarly process, entire process, all bits are processed. So you need to do this entire process. Bring next bit to the bit sequence, bring next bit to the bit sequence, bring next bit to the bit sequence till all bits are processed. So after all bits are processed, the final reminder is what? The 16-bit generator. Final bit is what? 16-bit reminder. So you need to get 16-bit reminder as the final CRC 16 reminder. So you need to get it by completing all the next bit into the bit sequence. Then only you will get the 16-bit sequence. So now after final CRC reminder, the data is what? 1011, and using the generator is what? This one, using CRC 16-bit polynomial, and the final 16-bit CRC obtained is the 111 1111 0000 0000 and 1111. This is the final CRC obtained is, final CRC obtained is. So after adding this final CRC obtained, we need to perform the transmitted frame. We need to append the transmitted frame. So the original data is what? 1011, and the obtained CRC is what? Obtained CRC is what? This one. So this obtained CRC you can add to this original data. You can add to this original data. This is the original data and this is the CRC. Now the transmitted code word is data plus CRC. Data plus CRC. So data is what? 1011 plus CRC is what? This one. 1011 11111 0000 1111. So this is the CRC reminder that you obtained 16 digit CRC code plus data. So this entire bit sequence is what? Transmitted code word. Transmitted code word. So like the way you can obtain the CRC reminder and form the transmitted frame. So this the transmitted code word that you can send to the receiver side. So this is the way you can compute the CRC 16 process, CRC 16 computation process. So here the thing is what? You need to get all the bits into the sequence. So how much sequence is connected for all the bits? Out of all this bit sequence, either the left bit is having 1, perform XOR operation. If the left bit is 0, leading the bit 0. So leading bits have to be removed. So like the way you can compute all the calculations. So what are the steps here? You need to perform what? We need to take the data, we need to append the 16 zeros to the data. So that is depending upon the CRC polynomial. If you are having CRC 12 polynomial, append 12 zeros to the data. If you are having CRC 16 polynomial, append 16 zeros to the data. Even if you are having CRC CCI TT also, you can append 16 zeros to the data. Then next perform modulo division. So in the modular division you can perform XOR operations. So whenever the 1 and 1 comes, it will be the 0, and 0 and 0 it will be the 0. When you are having 0 and 1, then only you will see only 1. Right. So till the process has to be completed, till all the bits are processed, and the obtained reminder will be the 16-bit CRC. Once you obtain the CRC reminder, CRC bit, you can use the transmitted code word. So transmitted code word equals to what? Original data, CRC, original data 1011 plus CRC obtained what? CRC reminder. So combine them, that is the transmitted code word. So like the way you can compute error detection codes, error detection techniques, CRC, 12 CRC, 16 checksums into the calculations or computation parts. Thank you all.